Unfortunately, that is where the Chinese stops. Not like Chuck, I can't give you the entire presentation in Chinese. So, what I'm going to do this afternoon is talk about Java SE7, which is the current release of Java. So, quick show of hands, who's using Java SE7? A few people. Who's using Java SE6? People. Who's using Java SE5? Okay. Who's using something older than Java SE5? We need to talk. Good. Well, Java SE7 is sort of, as I've said here, the evolution of the Java platform. And if we look at the history of Java, I joined Sun Microsystems back in 1996, so I've kind of lived through most of this. And Java was first released back in 1995. Now, has anybody used Java 1.0? No. Yes. Oh, okay. Yeah, you're probably still using Java 1.0, aren't you?
No, that's too
So Java 1.0 came out in 1995, and I do remember that because one of the really nice things about Java 1.0 was that there were about 200 class libraries in the standard class libraries, and it meant you could actually hold all of the class libraries in your head. You didn't need manuals, you could actually remember all of the classes that were available. Of course, that did mean that you were fairly restricted in what you could do, because there were a lot of things that weren't available. And clearly over time, what we've done is we've moved Java forward, we've added more things to it, so we went through Java 1.1, 1.2, 1.3, 1.4. Then marketing got involved. So we went from version 1.4 to version 5.0. And clearly that was a victory of marketing over engineering. But engineering still had some input, because if you actually look at the version number internally in the JDK, it's actually 1.5 rather than being 5.0. Then we brought out Java SE6. We dropped the 0 because we realized that there was never going to be a 6.1. So we thought, well, let's just call it Java SE6, and that will be it. And that came out in December of 2012. Then we had a little break. Well, actually quite a long break, because a few things happened after Java SE6 came out. And we started planning for Java SE7 straight away. But the things that really kind of slowed us down were that we open sourced the JDK. And that was a big thing. A lot of people say that we open sourced Java. And that's actually wrong. We didn't open source Java. We open sourced the Sun implementation of the Java development kit. And that's subtly different from open sourcing Java, because Java is three things. It's the language, it's the platform, libraries, and it's the virtual machine. So we open sourced the virtual machine, we open sourced the libraries, but we didn't open source the language syntax specification. I'll talk more about that as we go through. And then last year, we released Java SE7, which was the sort of follow-up to Java SE6. That was the first release that came out after Oracle acquired Sun. That was another thing which sort of caused a few delays in terms of Java SE7, some uncertainties over what was going to happen and so on. But Oracle, when we became Oracle, made some decisions. They wanted things to move forward, so we have Java SE7. Java SE8, the future, that's being planned. We're working busily on that at the moment, and that will be coming out in about September of next year. And we're even working on plans for Java SE9, all the way up to Java SE12. Now, one of the big things about Java is that in addition to being three things for a platform, language, specification, the virtual machine, and the libraries, it's also a lot about community. So the fact that I can turn up here on a Saturday afternoon and talk to you about Java is what we mean by community. Because I can't imagine there's many people who would actually go out of their way to do things on a Saturday afternoon that relate to their work. Now, most people, they finish work on a Friday, that's it. You know, they want to go home and be with their family and do their things at the weekend. But Java has a lot of passion behind it. People like Java. People like to get involved in Java. So there is this huge community that sits around the idea of Java. You've got the Java community process. You've got open source projects like Eclipse, like NetBeans. You've got the OpenJDK project. You've got Glassfish. All sorts of different places where people get involved. And there's huge numbers of open source projects that use Java. So there's lots of community involvement. Java user groups all over the place. And this is very important as well. Now, when it comes to actually thinking about how we can change Java, clearly if we want to make the next version of Java, we want to think about what changes do we want to make to the language. Lots of people have lots of ideas about what they'd like to see in Java. If you talk to any Java developer, there's probably at least one thing that they think would be a good thing to add to the language. And we have to be very careful about how we do that. What we try to do is to use the ideas which people like James Gosling had when the language was first created. And if you think about it, when Java was first released, there were lots of other languages available at the time. C, C++ being probably the most common. COBOL, Fortran, Algol, Smalltalk. You know, I can list literally dozens of languages that were available when Java came out. So what was the idea behind creating a new language? What was the thing that they were trying to solve that hadn't been solved before? And one of the real things that they wanted to do was to create a language that would be readable. A language which you could pick up and see what somebody else had written. And this comes back to what Chuck was saying in his presentation about looking at other people's code and understanding what they're doing and making it simple when you write code, because of course other people want to look at your code. You want to look at your code. I know, I've written quite a lot of code in my time, and if I come back to look at my code from 6 months ago, I have to think about what it was I was actually doing. I can't suddenly remember exactly what I was doing in that code. So the easier you can make it for a person to write code that is readable, the easier it is to maintain. And most of the time, the IT business, we don't spend creating new code. We spend a lot of time modifying existing code either to fix bugs or to make enhancements that our clients need. So we want a readable language. We want a language which doesn't hide things from developers. I'll give you a good example of how we did badly in that respect. In Java SE5, we introduced the concept of auto-boxing and unboxing. So in Java, we have objects. It's an object-oriented language. But we also have primitive types. If you want to add a primitive value to a collection, for example, you can't do that directly. You have to have an object representation. So we have the wrapper classes, integer, float, double, and so on. You have to create an instance of that wrapper class using the primitive value and then add that to the collection. Similarly, when you retrieve the result, you have to take the object and then call the appropriate method on that object in order to get the value. In Java SE5, as you know, we introduced auto-boxing and unboxing. Now the compiler would do some of the work for us. If we try to add primitive value to a collection, the compiler won't report an error. It'll say, what you actually want to do is create an object and add that to the collection. So I'll do that for you. So it automatically does it for you. Similarly, on the reverse, it automatically takes the object, calls the method, gets the value. That's all very good. I mean, it's a nice idea. It saves you work. But if you've ever read Josh Bloch's book of Java Puzzlers, he's got some very good examples of where that can cause you some very subtle problems, where the compiler does something and you're not actually immediately aware of it. You look at the code and you think, well, I'm using a primitive value, but no, you're actually using an object value because the compiler's auto-boxing it or auto-unboxing it. So those are the sort of things that we want to avoid. So, another question. Who here has ever used the programming language Perl? Anybody? One person. Okay, that's good because I can only upset one person in the room. So Perl I've used in the past for one project, and I firmly believe that Perl is a write-only language. Once you've written the code, it is impossible to understand what it is that you've done. And you're nodding your head. So, I mean, that's a little bit unfair to Perl because Perl is a very powerful language. But it does mean it's very hard to modify somebody's Perl code. And that's what we want to avoid doing. So these are kind of the guiding principles we have. Readability, simplicity of the language, and not hiding things from the user. Now the other thing is, what happens when we do want to change the language? It's not a simple thing where our engineers just go in and say, right, we want to add new features of the language, let's type in some code and boom, it's done. No, there's lots of things that actually have to be done. So we have to update the language specification. We have this full definition, using very precise language, using BNF notation to give you the exact specification of what the language will do, what the compiler will do, and so on. We have to change the compiler implementation. We have to change libraries that use that implementation. We definitely have to write tests to make sure that the thing will do what it's supposed to do. We possibly need to update the virtual machine specification, depending on what changes we're making. We have to think about changes to the JVM tools, the class tools. Maybe we have to update JNI, reflection APIs, serialization. Java docs definitely going to need changing. So there's lots of things that would have to be changed, even for a small change to the language. So this again is something we need to think about when deciding what we're going to do. How we actually go about doing that, in terms of making the decisions, is all done through the Java community process. Java community process was brought in quite a few years ago because Sun, at the time, wanted a way of involving people other than Sun in defining the future of Java. If you think about standard specifications, there's kind of two ends to the spectrum. At one end, you've got the sort of situation where one company decides exactly what goes into a specification. There's no public input at all. They simply say, here's what you get, and you use it, you like it or you don't like it, and that's what you get. The other end of the spectrum is an open standards organization. OSI, XOpen, POSIX, somebody like that. Now, the problem with that is that you have committees who meet and sit down to organize what it is that they're going to put into a particular specification. That gets very involved because everybody has to argue about it, and it takes a long, long time for everybody to agree about even the smallest detail. Certainly I've worked on some standards in the past, and I remember sitting in long, long meetings discussing the minutest detail of things. So the JCP was designed to be sort of somewhere between the two. We wanted a standards organization that could keep things moving quickly without having to go through long, laborious meetings, but wouldn't be us dictating what was going to be in the specification. Now, there were a few problems with the JCP, especially in the last few years. Most of that revolved around licensing of the compatibility test kit, dispute with Apache over the Harmony project. I don't really want to go into too much detail about that because it's all kind of water under the bridge, and we're never going to agree about what was the best way to do that. Ultimately, when Oracle acquired Sun and became the custodian of Java, they decided that they would make some changes and they would use the JCP to do that. They said, this is what we're going to do, and we had a vote in the JCP. Most people agreed, it's democracy, that worked, and so we moved forward. So now we've got a JCP which is moving again. What we also want to do is to make sure that it's relevant to the types of applications that people are developing today. And to that end, we've added some more people to the executive committee. The executive committee are the group of people who decide what specifications are going to be created, which ones go forward, and so on. So the people we've added there are, there's SuJava, who are the biggest Java user group in the world. They have about somewhere around 10,000 members. Most of them don't all turn up to the same meeting, it has to be said. But they are a very large Java user group. London Java Community is also a very active Java user group in London, and they work a lot with financial services organizations. Goldman Sachs, we wanted to get involved because of their use of Java in the financial services side of things, which is something that is very big for Java. So we wanted to make sure that it was represented well there. The other thing that we're doing is to actually reform the process itself. So we've got a JSR 348, so this is kind of like a recursive JSR, and we're changing the specification process so that there's more transparency. The idea there is that rather than having to wait until the public review of a specification, now you'll be able to see all of the mailing list and all the email that's going back and forth amongst the expert group, so that you can see exactly what's happening during the development of the specifications. So this is a good thing in terms of moving Java forward and making sure that people are involved. So Java SE 7, what actually went into Java SE 7? Well, as I said, there are three parts to the Java platform. There's the language specification, and we changed that. So we introduced this thing called Project Coin, and I'll go through the details of that. There are the class libraries, and we changed those. So we added some fairly significant pieces in terms of input and output simplicity. We also had the fork join framework for making parallel applications easy to write. And unusually, we changed the specification of the Java virtual machine. We've certainly made changes to the virtual machine in the past, but they've mostly been in terms of improving performance, adding different garbage collection algorithms, and so on. But from a functionality point of view, we've never really changed the JVM. In Java SE7, we introduced the first new bytecode that we've done since the beginning of Java. So Invoke Dynamic is all about making dynamically typed languages work better with Java. We'll talk more about that as well. A few other miscellaneous things, again we'll kind of come back to that. And then we had a JSR 336, which is what we call an umbrella JSR, and that covers everything that went into the actual release. Because you can see that various parts of this have their own JSR, so 336 is just bringing all of it together, and that lists exactly what went into Java SE7. So let's talk about Project Coin, the small language changes. Well, the first thing is, why is it called Project Coin? Well, coin in English has two meanings. Either means a small piece of change, so coins in your pocket is change in your pocket, or it's a verb which means to create a new piece of language. So you can coin a phrase, is what we say. So that's why it's really called Project Coin, because it is small changes to the language. Now, in terms of what we wanted to do with Project Coin, the key thing was to make small changes. One of the obsessions that we've had throughout the lifetime of Java is backwards compatibility. Making sure that you as developers have code which you don't have to modify if it's already working in order to make it work on a new release of the platform. Now we've been fairly successful in that respect. A couple of times we've had some impact. So in 1.4, we introduced assertions. So that was a new keyword, which meant you couldn't use assert as a variable name anymore, which broke backwards compatibility. In Java SE5, we introduced enumerations, so enum became a reserved word, and therefore you had to change any code which used enum as a variable name. Of course, as Chuck said, we all use very expressive variable names for our code, so nobody in their right mind would use enum as a variable name, because it's far too short and far too irrelevant. Of course, having said that, I then went and recompiled some of my code and discovered that I'd used enum as a variable name, so I had to change my own code to make it compile. But in terms of Project Coin, we wanted to make these changes small. We didn't want to introduce any new reserved words. We didn't want any changes to variable names that you would have to make. We didn't want to change anything in respect of the type system. So from a backwards compatibility point of view, this wouldn't have any impact. We also wanted to make sure that moving forward, these things would coordinate with things we were planning for future releases. So things like Lambda expressions, the Project Jigsaw modularity, when that comes out. And so this is what we're trying to do, to minimize the impact that these changes will have. So the first thing is just to make life easier for us when it comes to binary numbers. Binary numbers are used by computers, we know, and quite often we want to use a binary number in our code. Up until now, if you wanted to specify a literal number in your code, you could either do it as a decimal number, an octal number, or an hexadecimal number. So now we have the ability to put a binary number in. So you can do 0B, sequence of ones and zeros, and that will be converted by the compiler into the internal representation of that number. That's all very good, because that means now that we can actually put bit masks in our code and we can see what it is that we mean, rather than having to think in hex and translate from hex into our head in what's actually being said. The other thing we did was to allow you to put underscores into a number, so that you can break up the digits. Again, if we've got a bit mask where we've got groups of 4 bits, we can make it clearer for the developer to see exactly what it is we mean by that. And if we want to break up longer numbers, maybe phone numbers or something like that, it's just easier to see what's going on there. Small changes. that don't have a lot of impact. So the next thing, strings in switch statements. It is hard to believe that it has taken us 16 years to understand that strings are in fact constants, and therefore we could use them in a switch statement. But there it is, 16 years later we finally added strings in switch statements. One of the things that happened was obviously our engineers looked at strings and they said, well, they are actually immutable, so let's make them usable in switch statements. Question?
As I remember, C# already had this for, quite long ago.
I know. You see, this is why I have to stand here and go, wow, look at this great new feature we've added. I did actually ask James Gosling about this, because I said to him, why didn't we add strings in switch statements, right at the very beginning? They said, well, there were just so many things we were trying to do when we got Java launched that we just didn't quite get around to it. And it was one of those things that we kept meaning to put in, and it never quite made it to the top of the list. So finally now we do actually have it. Of course, one of the things that a lot of people ask me is, well, okay, strings are constants. Does that mean we could use any immutable object as a label in our switch statement? And I asked one of our compiler engineers about that, and he said, oh, no, that's very, very complicated. It's, strings are one thing, but making it, extending it to immutable objects, that would be far too complicated. So maybe we'll see that one day. So this is the kind of code that we have today without strings in switch statements. So if you want to do a comparison between a string and the month of the year, you end up with this rather complicated expression where you've got if statements, where you've got to do or, and you've got to do comparisons with the string. You've got to call equals method on the string and pass in the parameter and so on, all this sort of thing. So it is quite messy, and especially if you've got a lot of strings that you want to compare against, it can be quite error prone. Because if you get the combination of things wrong in your if statement, then you can very easily have an error. Switching that to a switch statement, he says using a pun, we can get a much cleaner looking piece of code, and therefore just tidies things up. Again, these are not big things, these are just more tidying up what we can do with the code. So that's a nice feature as well. Simplifying generics. Now, in Java SE 5, we introduced the idea of generics, which personally I think is a really bad name for this particular feature. I think they should be called specifics, because we already have collections that are generic. What we're actually making them is type specific rather than generic. But anyway, I never have got a good answer to why we call them generics. So at the moment, before generics, if you wanted to have a collection, like an array list, then you would specify it as an array list. Problem with that is, as we know, when you add something to that collection, it is an object, but it doesn't matter what kind of object it is. So in this case, we obviously want to store strings in it, so we can add strings to it. When you want to retrieve something from that collection, you have to explicitly say what type it is that you're going to extract. So if you've got a string and you want to extract the result from the array list into that string, you've got to do an explicit cast to string. If the object that you've added to that collection is not a string, and you try and cast it to a string, then you're going to get a class cast exception at runtime, which is a bad thing. So we introduced the idea of generics in Java SE 5. That was all very well and good. So now we have a type parameter with our collection. So we say list of type string, strlist, equals new array list of type string, to call the constructor. I must admit, when I first looked at this, I thought to myself, why? Why do we do it this way? Because if I'm creating a list of type string, surely the compiler is going to know that the array list is also of type string. So why do I have to specify string twice? Never did quite understand why that was the case. And obviously, if we make things more complicated, we get a situation where now I'm going to have a list which has got a type parameter of map, which has in itself got type parameters of string and list of type string, and I have to specify that twice. Once for the definition of the variable, once for the definition of the type of the object that I'm creating. And that just doesn't really help us a lot. So what we're doing now is to say, okay, we'll make that simpler by using what we call the diamond operator. And that simply says that in the second type parameter definition, you can leave out the definition. So if you leave it empty, the compiler will say, okay, list of type string list equals new array list, and because you're creating a list of type string, you must be creating an array list of type string. So it does the type information for you. Now it's not quite as simple as doing a simple string substitution. So you can't simply say to the compiler, well, the compiler is just going to take string or whatever is in the first type parameter and put it in between brackets and then compile it. It requires proper type inference, and that's why it's a little bit more complicated. Certainly if you get into using some of the wildcards in generics, then there's some more complex things that the compiler would need to do in order to figure out what exactly is the type for the second one. But ultimately it can do that. So we now have a simpler syntax for defining generics. Copying a